Hi, this is Richard C. I'm a math tutor here at Wyzant, answering a question submitted by a student. This has to do with graphing cosine function. The way to approach this is to start with the parent, the way the parent function looks. So I'm going to put that in a color. We'll use green here. If I just wanted to graph y equals cosine x, the graph would look like this. It would start at 0, end at 2 pi. This would be the midpoint here at pi. Okay. Now, instead of that, we're going to graph a transformation of this parent, cosine x. A general form of the transformation, I'll put in red, would be y equals a times the cosine of b times x minus h plus k. And for the transformation, you have to realize that h is the horizontal shift left and right. K is the vertical shift up and down. Absolute A is the amplitude. And 2 pi over absolute B is the period. And I think you can see in the parent here, I'll go back to the green, you can see that there is no horizontal shift. It starts at the top here, which is going to be 1. There is an invisible 1 here telling us that the amplitude is 1. So the maximum value will be 1, the minimum value will be -1. And because B is 1, the period is going to be 2 pi. So you can see the period is just 2 pi because 2 pi over 1 is 2 pi. Amplitude is 1, meaning it's a distance of 1 from the midline up to the maximum, or from the midline down to the minimum. Now, our particular graph that we want to draw today, I'll do this in purple, is, oops, that did not come out purple. Come on now, purple guy, let's go. Okay. So the problem here is, y equals cosine of 1/2 x. And we see that h is 0 here because there's nothing being subtracted from the x or added to the x. H could be negative, in which case you'd be adding a value to the x. There's no vertical shift, so that's 0. The amplitude is still 1 because this is an invisible 1 in front. And we just have to find the period, which is going to be 2 pi. B is 1/2. And so our period is going to be 4 pi. So now that we know that there's no horizontal shift, there's no vertical shift, there's no change in the amplitude, all we have to do is take our green graph and modify it to deal with the period. So the period is just going to be stretched out. So originally it was 2 pi, now it's going to be 4 pi. But it will still start at 1 here. And then the lowest value would be -1. And it will start at the top, only now it goes, oops, let me just fix that a little bit. We start at the top, but now we're going to go down. Our minimum is going to be reached at the midpoint, and then back up through here, and then up to the top. Now, the problem asks us to graph from negative 2 pi to positive 2 pi. So we need to extend this. I would extend it. Usually teachers want to see a graph for 2 periods, 2 full periods. Each period for this guy is 4 pi. So I'm just going to do what most teachers would ask for here. And we'll put in our negatives. And then you can see, so we're going to reach the minimum here and then come back up and over. Now, because the question is asking from negative 2 pi to positive 2 pi, all we need to worry about is that middle portion, which I'll shade in blue. So it would be, if you wanted to, you could just submit this just for this region here between negative 2 pi and 2 pi, and you could submit to be precisely exactly what they're asking for. You would just, sorry, my shading is getting a little tricky here, but you would just, basically you would submit a graph that looks, I'll put it over here so you can see it better. This would be 2 pi here, this would be 2 pi here, and it's going to go from a minimum let's see, what is this? From a minimum to another minimum here, here, and here. And so it's just going to go like that. It's going to look a little bit like a parabola. And this is going to be a 1 here. So that's technically what the question is asking for, is just this middle section. But I think it's kind of nice to show you 2 periods, because that's what teachers typically want to see. That's typically what they're asking for. And you can see that this particular question isn't that hard, because the only change that's being made from the parent function here is a change in period. There's no horizontal shift, there's no vertical shift, there's no change in the amplitude. It's just the period that's being changed. And basically, it's just being stretched. You can think of it as a stretch horizontally and vertically. And I think that's a good way to think about it. If you studied scale changes, horizontal scale changes, this is exactly that. It's exactly the same thing that you might have studied with traditional functions. The same kind of effect occurs with trigonometric functions. Okay, so that's all you needed for today, and hopefully you'll finish out your pre-calculus course pretty soon, and you'll be free for the summer. But until next time, rather, bye-bye.